Aloha kids, I'm going to go over some of the 9.4 for you. First off, don't be afraid to look at your book. This is one of the biggest weaknesses of students nowadays is not reading this, getting the variables in there. We're working with the tangent ratio here. Remember, opposite means opposite leg. Adjacent means adjacent leg. You also have to identify the hypotenuse, whether they ask you to or not, because you've got to be able to distinguish that between that and the adjacent leg for angle A. Don't forget they also have examples in here for you can use. Practice. Another example, this is finding a leg length. You can also look up a lot of this stuff in YouTube. This example 3, I forget which problem this relates to. I'll mention it later. But they mentioned you got one problem that's using special right triangles on your work here. And you've got some applications here. And let's take a look at this. So, number 1 is just getting the length of the two sides that you're using in the tangent ratio, which they give you back here, right there. Okay. For number 2, this one's a little tougher. Explain how you know the tangent ratio is constant for a given angle measure. Well, if you have a given angle measure in a right triangle, that gives you an AA similarity proof right away. You've got that angle, you've got the right angle, they're similar. Since you have the similarity in the triangles, now the corresponding side lengths are going to be proportional and that ratio is going to be the same or constant. So this one here, again, we're just using tangent, which is the opposite leg over the adjacent leg. You just got to go through, find the tangents of the acute angles of the right triangle. So you're going to be doing multiply. You're going to be finding tangent of S and tangent of R. You've got to do both of those. Remember, they're different. For angle S, that's your opposite side. That would be your adjacent side, since this side is connected to the angle S. It forms the angle S. Don't forget, for R, this is your opposite side. But on all of these, you're doing it for both of the angles. You got to get both of those angles. Remember, they're not going to be the same. Also, watch for the pattern in the answers on these. There's a pattern that comes up in all of these. This one is you're solving it. So we've got our angle. This is our opposite side. This is our adjacent side. So that's going to be tangent of 41 degrees equals my opposite side. That's 12 over x. Again, you can cross multiply and solve, or you will notice it just ends up switching these two numbers. So x equals 12 over tangent of 41. You do have to be careful putting that into your calculator. Number 8, this is my opposite side. This is my adjacent side. So it's going to be tangent 27, whoops, that's a poor 7, is my angle. That's going to be x over 15. When the x is in the numerator, you can just multiply by 15, multiply by 15. 15 times tangent of 27. Plug that in your calculator. You got your answer. These two are similar type problems over here. I think they're a little bit more like 12. They're being a pain to you here. Mistakes, number 11. I'm going to let you look for these. Okay? I'll give you a hint on number 12. What is missing from the diagram in 12 that you can see in the diagram in 11? So, this one, see example 3. So remember, for the 45, 45, 90, you've got x, x, x root 2. Set up your proportion using those. For the 30, 60, 90, this is your 30-degree angle down here. X, x root 3, and 2x. Set it up. Remember how to rationalize the denominator. If you get that square root in the denominator, if it's in the top, you're fine. Don't forget the x's can reduce out. Okay, 15. Survey is standard 118 feet from the base of the mountain. So 15, make sure you've got some paper out, I should mention that. You've got your monument here. There's the monument. There's your ground. You got an angle of elevation going up over here. That's 78 degrees, even if I didn't draw that very well. This is the height I want to find there, and they tell us we're 118 feet. Whoops, not degrees. Feet from the base of the monument. So again, you're setting this up. Don't forget you got opposite. You got hypotenuse, not hypotenuse, sorry. Adjacent right there, that's adjacent to the 78. Tangent of 78 degrees equals 8 over 118. It's just like these earlier problems you did over here in 7, 8, 9, 10 now. Same thing here, you've got your diagram. These are both 55 because they are corresponding angles actually. Think about it. You've got two parallel lines. They're cut by a transversal. Those are corresponding angles. If I drew this out a little bit more like this, whoops, that's a bad line. You could see those are corresponding angles. That's matching up with this over here. Set up your equation and solve it. So on this one, just remember how this is going to look. 5, 12, 13. Which is your smaller angle? Is this your smaller angle or is this your smaller angle? Okay, so find the tangent of that smaller angle. '18 is similar. You're setting up a 3, 4, 5. This time they want the larger acute angle. Remember, in a right triangle, the other two angles are acute. Remember, the larger angles across from the larger side. So 4 is the larger side. Which angle's across from that? Set it up. 19's a thinking problem. So just think. I've got this over here. Let's look at this angle right here. That's my opposite. That's my hypotenuse. As I increase that angle, what's happening to this side? What's happening to this side? What's that going to do to my tangent ratio? That's what it's asking you. Another critical thinking problem. For what angle measure is the tangent of an acute angle in a right triangle equal to 1? Okay? So if the tangent, which is opposite over adjacent, is equal, I write like junk, is opposite over adjacent, that's equal to 1. What do you know about these two numbers? How do they turn out to be 1? Okay? And then when is it greater than 1? That kind of relates to number 19 and thinking about when you increase that angle. less than 1, same thing. Okay, kids, I'm back. You didn't even know I was gone, but I just went and recorded that KCAB that hopefully most of you watch, and if you didn't watch it, go and watch it. So we're on number 21, I believe, here, and my pen's not working, so let me fix this really quick. Okay, we got that working. So on this one here, you got your diagram down here. You got your feet. Now we're using this angle down here. That's not a good color. We're using this angle. Dang, pen stops working all the time. Okay, I think I got the pen working. We're using this angle down here. This is our little triangle, but we got to think. So it tells you the angle of the sun is 70 degrees, but be careful here. We know that this is a right angle. It tells us that right here. So that means this is 90 degrees. If this whole angle is 90 degrees, and again, my pen just wants to stop working. What's this angle going to be right here? What plus 70 gives you 90? That's the angle you need to use in the problem, so be careful with that one. '22, you could have noticed this when you were doing these ones up here. There was a pattern you should have noticed on those. And this is just really bringing it out here. You're using the A and the B. Not going to use the C because that's the hypotenuse, and tangent just uses adjacent and opposite. So set up your angles, explain how they're related to each other, what kind of angle pair is A and B. Again, what do these angles add up to? Since we know this is a 90, we've talked about this. This is a rule earlier in the class. And then the last thing you got to do here is our special right triangles, 45, 45, 90, and a couple 30, 60, 90s. That information has been presented to you before. I'm going to let you look it up. We'll catch you later. You all have a good one. Take it easy.